My name is Marlon Velasco from VSIT3C, and here is my video documentation about my proposed title, Enigma Cipher, the modification of Caesar Cipher using different shift and position. Base cipher process, a Caesar cipher. So as we can see in this diagram, it is an encryption process. In this example, I use a left shift of 4 to be encrypt the word Marlon. To do this, we count 4 moves of letter to the left. Then now we can already substitute the plain text into the ciphertext. M becomes I, A becomes W, and so on. And as the result of the ciphertext using left shift of 4 was I, W, and H, K, J. Decryption process. So in this diagram, I use of example right shift of 24 to be decrypting the word I, W, and H, K, J. To do this, we count 24 moves of letter to the right. Then now we can already substitute the ciphertext into the plain text. I becomes M, W becomes A, and so on. And as the result above, the ciphertext using right shift of 24 was Marlon. While in my modification, I used different shifting key that added or subtracted to each characters of plain text or ciphertext. Then in encryption of the if the result was greater than to 26, it need to mod to 26, the ciphertext. Then in decryption, if the result was a negative number, it need to mod to 26 to get the plain text. So in this part, it's all about my proposed algorithm process, Caesar Cipher using different shift and position. In this diagram, which is encryption process, where the plain text was Marlon and the fixed position of this on the alphabet was 13, 1, 18, 12, 15, and 14. And my shifting key was 2, 4, 6, 8, 10, and 12. Shifting key is not repeated because it has the same length to the plain text. The result of the sum of position in the alphabet and my shifting key was 15, 5, 24, 20, 25, and 26. Then the result of their sum was below 27, so no need to mod 26 and convert it to alphabet and you will get the result O, E, X, T, Y, and Z. Here in decryption process, in this diagram, which is where the ciphertext was O, E, X, T, Y, say, and the fixed position of this on alphabet was 15, 5, 24, 20, 25, 26. And my shifting key was 2, 4, 6, 8, 10, and 12. Subtract it to the fixed position and you will get the answer, which is 13, 1, 18, 12, 15, and 14. Then I use six shifting key that's subtracting to each value of characters of ciphertext. The shifting key is not repeated because it has the same length to the ciphertext. The result of their subtraction was positive number, so no need to mod 26. And then convert it to alphabet. The result was the plain text of Marlon. Here is my Python codes. So in my Python codes, I create a list of alphabet. It will help to get the position of characters based on alphabet. I generate a key to match the length of the key to the key text and declared no changes when same length while there is a repetition of shift numbers to match the text size. For the driver code, the user are continue asking whether user want to encrypt by choosing E and decrypt by choosing D. Then after choosing whether they want to encrypt or decrypt, they will ask to give their one shifting key or their assigned shifting key. It will pop up like this. What is your six shifts? Then if the user done giving their six shifts, the answer will automatically appear. Now let's try to encrypt and let's implement into Anaconda Python. So here is some example. First choose E to encrypt and enter plain text which is Marlon. Enter six ships 1, 2, 4, 6, 8, 10, 10, 12. And the result is ciphertext OEXDYZ. So now let's try to decrypt. D for decryption. Ciphertext is OEXDYZ. Then it is asking for the what is our six ships. Which the ship one is 2, 4, 6, 8, 10, 10, 12. So the original text was Marlon. Let's try another example. I try using more than 6 characters to know if it is properly working. So basically, if 6 ships will met, the corresponding characters will go back to assigned number, which is ship 1. First, choose the encrypt, which is letter E. Enter our plain text. So in this example, we will using word anonymous. Anonymous. Our first ship is 6, 9, ship 2, 8, 6, 9, 8, 3, 4, then 13. So our ciphertext that appeared are GWWQC, say, U, D, and A. So now we will decrypt it. So choose D to decrypt and enter ciphertext, which is GWWQC, say, U, D, and A, and fill up our shifting key, which is 6, 9, 8, 3, 4, and 13. So, as we can see, the original text is anonymous. Then this is the end of my Python codes. Thanks for watching and giving your time to hear my explanation. Have a great day.